Welcome back to the rest of 6.1. Going to look at special right triangles. There's two special right triangles. They have specific angle measures, and no matter what size the lengths are, they always have the same ratios. The lengths of the sides always have the same ratios. So, a 45, 45, 90 triangle. Draw a right triangle, make it look like it has a right angle. Don't draw a crummy triangle. Make it look like a right triangle. When the angle measures are 45 degrees each, okay, that gives us two congruent angles, which means the two legs opposite those are equal lengths as well. So, with there being two side lengths congruent, that triangle is isosceles. It has a right angle, so this is an isosceles right triangle. Now, the key here are the ratios of the sides. The ratios here are side, side, then the hypotenuse is side times square root 2. That's always the ratio of the sides of a 45, 45, 90 right triangle. Whatever the legs are, the hypotenuse is multiplied by square root 2. So let's look at A. We do have two congruent sides and a right angle. This is a 45, 45, 90 right triangle. May be useful to label the ratios on the inside of the triangle. S, S, S square root 2. YZ is 5. Well, that's S. So the other leg is 5, and that hypotenuse is 5 times root 2. So XZ is 5, and XY is 5 square root 2. Now, this works out nicely when the X, the length of the leg is given to you. That won't always be the case. So let's look at B. The triangle's rotated, but that's fine. We still have two congruent legs and a right angle. So it is a 45, 45, 90 triangle. Each leg is S. The hypotenuse is S square root 2. We're given that JK is square root 3 over 7. Now, what that means is that S square root 2 is equal to square root 3 over 7. Now, we want to solve this for S, that side length. To do that, we need to divide both sides by square root 2. So S equals square root 3 over 7 root 2. Now, we can't leave that root 2 in the denominator. We need to multiply top and bottom by root 2. So that side length is square root 6 on top over 7 times 2 on bottom. So those side lengths are square root 6 over 14. So KL and LJ both equal square root 6 over 14. Now, our other triangle is called a 30, 60, 90 triangle. Again, it's a right triangle. As you draw it, make sure one angle is definitely supposed to be a right angle. The smaller of the other two angles is 30. The larger is 60. Now, this one does not have another name. None of its sides are congruent. None of its angles are congruent. What matters here is what is across from what. What's opposite from what. So from the 30-degree angle through the triangle across, we call that side X. From the 60-degree angle through the triangle across is X root 3. From the 90-degree angle through the triangle across is 2X. And here are the ratios of a 30, 60, 90 right triangle. So, in part A, we have a right triangle with a 30-degree angle. Across from the 30, we label X. The other acute angle would be 60. Across from that 60, we label as X root 3. Across from the 90, the hypotenuse, we label as 2X. Now, we're given that SR is 7. So again, we have a little equation here that tells us that X root 3 is equal to 7. To solve that, divide by square root 3. So X is 7 over square root 3. We can't leave that root 3 in the bottom, so we multiply by root 3 over root 3. This gives us 7 square root 3 over 3. And that is X. We cannot divide out those 3's because one is under a radical and one is not. So ST is 7 root 3 over 3. That's the X. Then RT equals 2X, which is 2 times 7 root 3 over 3. Multiply straight across. RT is 14 square root 3 over 3. Remember, this would be 2 over 1, so multiplying straight across. And looking at that next example, again, we have a right triangle. One angle is 30. The other acute angle would be 60. We can label this as a 30, 60, 90 right triangle. Across from the 30-degree angle is X. Across from the 60-degree angle is X root 3. Across from the 90-degree angle is 2X. We're given that RT is 2 root 5. So we have the equation set up. 2X is 2 root 5. I'm really trying to write that 5. And then we divide both sides by 2. And they happen to divide out on both sides. So X is square root 5. And that is side RS. RS is square root 5. Then to get ST, that's X square root 3. X is square root 5. So we have square root 5 square root 3. Multiplying that together, they're both under a radical. Multiply them under a radical. ST is square root 15. There is a refresher on special right triangles. We'll be using these very, 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 very often as we go forward. You have a great day.